Within the modern-day society, it is imperative to incorporate science and mathematics within technology activities as it creates more meaningful learning experiences, assists in creating links to solving real-world problems, and prepares students for the future learning. By embedding the units of science, technology, engineering, and mathematics together creates what is called STEM. This can be defined as an integrative approach to curriculum and instruction. STEM education can be applied using a constructivist approach to teaching and planning activities. This constructivist approach surrounds the idea that problem solving is at the heart of learning, thinking, and development. When implementing the constructivist approach within the classroom, the student should rely on two major elements. These are prior knowledge to actively construct new information into their mental framework for meaningful learning to occur, and have their STEM work based upon real and authentic problems that creates active participation of learners in problem solving and critical thinking. Therefore, by doing this, it should inspire creativity, inquisitive thinking, and teamwork. For example, this constructivist approach can be seen within Week 2 activity, Who Sank the Boat? This activity was inquiry-based as they were presented with some prior information from reading the book by Pamela Allen in their English unit. Then, by researching materials that would make a great boat, followed by designing and constructing their own boat that met the design challenge requirements of being able to hold 10 marbles representing the animals within the book. This activity was then extended to see how many marbles the boat could hold until it sunk. Learning STEM within the classroom has significant connections to the real world we live in. As teachers, it should disturb us to know that the students' enthusiasm for their personal learning is fading. Hence, they must be persuaded to re-engage into their learning. Through the implementation of STEM education, the students can comprehend the transfer of learning to real-world contexts and are taught to solve new problems. In addition to this, by teaching and implementing strategies such as problem-based learning through a STEM curriculum may reinvigorate the students' desire to understand the world around them and encourage them in classroom instruction. This can be seen through the activity Building Pee-wee the Kiwi a House. The connection between design technology, science, and mathematics is evident to the students as displayed in the shown diagram. As you can see, the connection of design technology refers to producing design solutions using varying materials, then connecting to mathematics through measuring and comparing, and finally, science involves observing, asking questions, and describing changes in objects and events. Students are able to research where kiwis live and what sort of environment they live in order to build Pee-wee a suitable house. If the lesson was taught in New Zealand, there would be a possibility to further their learning by taking students on a field trip, linking it all back to the real-world context. Finally, STEM connections within a classroom environment prepares young learners for the future. Students will have to inquire and answer critical socio-scientific questions associated with upcoming worldly issues, like sustainability, climate change, and renewable energy. Therefore, teachers must present scaffolded inquiry-based questions and teachings within the classroom so that students not only learn STEM content, but also learn skills they will use in their near futures. And I'd just like to leave you with this quote as food for thought. The future belongs to the curious, the ones who are not afraid to try it, explore it, poke at it, question it, and turn it inside out. Thank you.